So hello level 3 physicists, continuing on with level 3 mechanics, mechanical systems. Today we're going to look at gravitational force. So to begin with, what is gravity? So here are 3 ideas. Pause the video now and just consider which one of these do you think you agree most with in terms of what is gravity. Okay, so welcome back. So in terms of what is gravity, the idea that most closely aligns with the kind of physics principle of what gravity is idea number 3, that all mass attracts all other mass. So there you go, boys, you are indeed attractive. So in order to understand gravity, at least in the context of the mechanics, we have to understand the universal law of gravitation, which the great Newton introduced. Okay, and it essentially says that the gravitational force equals some sort of gravitational concept multiplied by the mass of one object multiplied by the mass of another object divided by the distance between those two objects. Okay. So the gravitational force, the symbol is F, capital F, and the units being force are newtons. The object 1 mass is big M, and that is of course because it's mass in kilograms, and objects 2 mass is little m, and again just like the object's 1 mass, it's in kilograms, and the separation distance r is of course being a distance measured in meters. So in terms of the universal law of gravitation, you'll also see that big G. That big G is the universal gravitational constant. And big G equals 6.67 times 10 to the negative 11 Newton meters squared per kilogram. Okay, and that constant will be given to you so you don't have to memorize it. So gravitational force, it is both equal and opposite. So what does that mean? Well, here we have a lucky skydiver skydiving towards the Earth from space, I guess, the vacuum of space. And what that's saying is that the force of gravity, or the attractive force of gravity on the skydiver is equal and opposite to the gravitational force that the Earth is experiencing from the skydiver. Okay, that's kind of possibly counterintuitive for you, but with gravity, the forces involved with the two masses are both equal and opposite. So in terms of measuring the proper distance, so you'll notice also that was in the last slide, you'll notice that technically the law of gravitation from Newton is between 2 point masses. Okay, so obviously you're not a point mass. Planet Earth, not a point mass. It has quite a bit of a volume. But we'll just basically make an assumption that for a spherically symmetrical shell of a certain mass, like a sun or a planet, it will act as if the mass is located at the center. And it's the same actually for you as well. We make the assumption that the mass is located at the center of mass, which kind of makes sense. So that's an introduction to gravitational force, and then next lesson we'll look to apply that concept around satellites and motions with rockets and the like.